Now we're going to move on to the next segment where we interview Greg John, who is the manager of the state parks here. Greg is going to tell us a story about a particular storm event that happened here. Hi Greg, thanks for being on the show with us again this year. So you're the manager of the park here?
That's correct. Been here 20 years.
Can you tell us a little bit about this?
I know.
Can you tell us a little bit about this land where we're standing here?
Yeah, the land that we're standing on was created back in 1969. If you can imagine, out here in the water, there were dredges that brought material out from out here in the water, in the bay, and deposited back up here, and also trucks coming down the road and depositing material here as well.
So what you're saying is that this used to be mud flats and eelgrass right here, and we created this place for the parking lots and the picnic tables.
Correct, exactly.
And that was back in the 60s.
69.
So has this land been eroding away?
Yes, it has. If you look at the beach a number of years ago, I think it was 2 years ago, in '07, we put about 800 yards of material down here on the beach. Basically, as a beach feeding, sacrifice some material to keep the rest of the core of the beach whole. And each year, some goes away. One event we had in November that year, within 3 days, all that material left from here on the beach and was deposited to the north.
We've got a rope laying on the beach here, Greg, and if we get the students to help us, maybe we can show how much material you had deposited on the beach at that time.
You bet. So pull it out a little bit straighter, guys, a little bit higher. So roughly 22 feet of material was dumped, and then it sloped down this direction. And if you look around here, you can see how much of the sand has actually been moved to the north.
So right now where the rope is being held up, that's what the level of the beach used to be. And then in one storm event, the waves came in and removed all of this soil. So you can go ahead and drop the rope, show how the soil was washed away to the level it's at right now.
Correct. And you want me to show you the different particles of sand? What we
Sure,
used?
let's take a look.
If you look at the difference in the sand, this is what normally naturally occurs. This is what we deposited here in my right hand. And the idea behind that was to have material that was bigger, harder to be moved by the wave action and the winds, and also for salmon. So you don't have a lot of material suspended in the water. So that's the difference.
Thanks, Greg. So this was a big storm event that came in here and carried away all this material. We do get some violent storms around here. I'm wondering if any of these high school students have some experiences of their own from storms that we've had around here. Allison?
Yes.
You're from which school?
I'm from Cedar-Woolley High School.
Cedar-Woolley, that's the one that's up here in the river delta.
Yes.
Can you tell us about an experience you've had recently with storms?
My family lives upriver and it floods each year. Our fields get mostly covered in water. A lot of the grasses are eroded and bare dirt is just left and our fields get filled with debris. Lots of garbage is washed into our fields.
What was it like for you?
We had to clean up a lot of stuff.
Yeah, I'll bet. How about another student here? Can you introduce yourself, please?
Hi, I'm DJ. I also go to Cedar-Woolley High School. I also have one experience with flooding. This last year when we had a hard rain, my river down the road flooded and I was forced into my house for 3 days, not being able to leave. So that was pretty scary.
It was scary for you?
Yes.
Anybody else have a brief flooding story you want to tell? Anybody do any sandbagging? That's a common thing for people around here. Blas?
Hi, I'm
What
Blas.
school?
I'm from Cedar-Woolley High School.
Tell us about sandbagging.
My story is a town about a couple miles from here called Mount Vernon was flooding, so I got together with some volunteers and we started sandbagging, help out the local businesses with lower their costs from destruction and stuff. Yeah.
I have a sandbagging story.
You have a sandbagging story too, Allison.
Our school does FFA competitions, and at the Mount Vernon Fire Department, we competed against several other schools and who could sandbag the fastest, and all those sandbags were donated to businesses when it did flood, and they got to use a whole bunch of sandbags that were already made.
So you see, the point that we're trying to make is that this is an area, because it's a river delta, it's very low and flat. And so we are in danger of erosion and flooding and these kinds of storm events. The reason it comes up for us right now is we're talking about sea level rise. And sea level rise is something that happens very slowly over time. But we don't experience the drastic effects of sea level rise slowly over time. It's something that happens suddenly when a storm event happens, like what happened in New Orleans with Katrina, for instance. Now, the eelgrass and the mudflats that John Rybsik was looking at, that's a little different story. As the sea level rises, there are some eelgrasses that are at the deepest edge, where it's almost too deep for them. And as the water becomes deeper, we're afraid that those seagrasses may die out. But on the other end, where it's too shallow for them, as the ocean gets deeper, there's a possibility that the seagrasses could move into that area. So that's what John Rybsik was looking at with his research. If we can bring in his map over here, and John, if you could come in and explain
Sure.
the results of what you think you were able to predict.
Right. Well, from the video that you saw earlier, we are taking measurements of what is happening now. But we want to ask the question, what's going to happen to the eelgrass beds, which are very valuable, in the next 50, 100, 200 years? And to answer that kind of question, we have to do and use computer models. And this is a graphic of one of the outputs from the computer model. Over here, you can see this is essentially the bay, Padilla Bay here, and the extent of the eelgrass right now. The green is the eelgrass. And the darker the green, the more productive it is. So this is the situation right now. So we can ask the question using the computer, what happens if the sea level rises 0.56 meters in the next 100 years, which is a pretty good guesstimate as to how far the seas might rise in that amount of time. Run our models and look at where the eelgrass will be then. And you can see for Padilla Bay, it's not too bad. As Alex was pointing out, you can see there's not really that much difference. We'll see an inward migration of the eelgrass. Those on the deeper end will start dropping off because the water is too deep, but they'll start colonizing some of the shallower areas where it's too shallow for them right now, and they would die otherwise because of desiccation. So over the next 100 years, we'll see a lateral migration. Now, if the sea levels rise even more, we'll eventually start seeing eelgrass being squeezed out on the shallower end and dying out on the deeper end. So that's when we'll have the biggest problems.
So just to recap what we've been going over here in terms of sea level rise, we're predicting that the depth of the water will have some effect on the eelgrass here, and also on the people that live in this part of the world. But the people are going to experience these changes more in sudden storm events, while the eelgrass may have to migrate slowly or experience these changes slowly over time.